you putting your head inside the refrigerator?
It's too hot outside.
I have an idea for you. How about we build an igloo house?
Boom. How can we build an igloo house?
We're gonna freeze the water.
How much water do we need?
We will use chill method, but we also want to save the world, so we use that method to calculate how much water we need.
I don't know how to use the chill method.
I will teach you how to do it.
Okay.
Good. Let's see what we have now. We have a graph of y equal to x minus 2 squared multiplied by x minus 1. We also have an area enclosed by the graph of y, x-axis, x equal to 1, and x equal to 2. So we want to rotate this area about the y-axis. After the rotation, we will get the new shape below. We want to find the volume of this shape. In order to find the volume of this shape, we use a method called shell method. So, to use the shell method, we need to construct the shell. A rectangle can be constructed on each x in the interval of the area. If we rotate the rectangle about the y-axis, the shell is constructed. How to find the volume of this shell? First, we need to analyze the rectangle that we have constructed. Let's say that the width of this rectangle is dx, and the height of this rectangle is function of x, which equals to y. After that, we will use the information to find the circumference of the shell, the surface area of the shell which can be found by multiplying the circumference by the height. Now we can find the volume of the shell by multiplying the surface area by its depth, or dx, which is the width of the rectangle. The circumference of the shell is 2 pi multiplied by radius r. For the shells, its radius is the distance from the origin to the rectangle, which equals to x. Therefore, the circumference will be 2 pi x. Next, we need to find the surface area of the shell. It equals to the circumference multiplied by the height. For this shell, its height equal to function of x. So, the surface area will be 2 pi x function of x. For now, we can find the volume of the shell already. The volume of the shell equals to the surface area multiplied by its depth. Hence, the volume of the shell equals to 2 pi x function of x dx. Now, let's think that this shell is tiny depth shell, because we are assuming that dx is tiny value approaching to 0. To find the whole volume of its shape, we need to construct a lot of shell and add them together. To do that, we use definite integral of the volume of the shell. For this graph, the definite integrals had an interval of x from 1 to 2. So the whole volume of this shape is the integral of 2 pi x function of x dx, when x is from 1 to 2. 2 pi is a constant, so we can put it in front of the integral. Function of x can be replaced by x minus 2 squared times x minus 1. And the value of this integral is the whole volume of the shape. Let's analyze this integral again. X represents the radius of the shell, and the function of x represents the height of the shell. From that information, we derive the general formula to find the volume by shell method. Let's say we are finding the volume of graph using the enclosed area from x equal to a to x equal to b. The volume equals to the integral of 2 pi p of x h of x dx when x from a to b, and h of x represents the height of the shell. Now, we could find the volume of our igloo house. Let's say that we have two curves, y equals to negative x squared plus 2 and y equals to negative x squared plus 2.5. Those curves could construct an igloo house with height of 2 and thickness of 0.5. First, we see the area between two curves y-axis and x-axis. Rotating this area above y-axis can construct the igloo house. To find the volume by shell method, we need to analyze the rectangle. This rectangle will rotate about y-axis to construct a shell. From the general formula, the volume of the igloo house is 2 pi times integral of p of x h of x dx from x to a to x to b, which p of x represents the radius of the shell. For this graph, the radius of the shell equals to x. H of x represents the height of the shell, which equals 2y of the upper curve minus y of the lower curve. So h of x is negative x to the 2 plus 2.5 minus negative x to the 2 plus 2. We are considering the graph of x equal to 0 to the 0 of the upper curve. Therefore, the 0 is at x equal to square root of 2.5. Then, we are finding the integral from x equal to 0 to x equal to square root of 2.5. The radius is x, and the height is 0.5. I am plugging this into the calculator. The value of this definite integral is approximately 3.927. Therefore, we need to freeze about 3.927 meter cube of water to build the igloo house.
And we are finally done.